Hello friends, today we are going to discuss a very important topic in the railway industry, railway safety. We will look at how safety has evolved, the concept of functional and technical safety, and one of the most important safety principles in railways, the fail-safe concept. Introduction to railway safety. Safety is not just one part of the railway system. It exists everywhere. From the tracks, to the train that run on them, to the staff who operate them, and even the rules that governs operations. Right from the early days of railways, people realized that even small mistakes could lead to serious accidents. So safety has always been a core element of railway operations. Evolution of railway safety. As the railway system developed over time, safety systems evolved along with it. The goal has always been the same: to reduce dangerous situations and bring the risk of accidents down to acceptable levels. In the beginning, railway safety mainly depended on rules and basic signaling systems. But as trains became faster and busier, more sophisticated safety systems became necessary. Early safety systems. The earliest safety measures were simple traffic regulations and trackside signals. These were helpful, but they had one major weakness: they relied heavily on humans. Human error is unavoidable. Even a small mistake by a signal operator or a controller could lead to an accident. This led by the development of automated systems to reduce dependency on human decisions. Advanced safety systems. To address these issues, several advanced systems were introduced. Interlocking systems prevent conflicting train movements. Block systems ensure trains maintain safe distances. In-cab signaling systems give real-time movement authority information to drivers. Each improvement pushed the railway sector towards safer and more reliable operations. Continuous improvement. Even today, safety in railways continues to evolve. New technologies, new regulations, and specialized safety organizations play a major role in maintaining and improving safety standards. The focus is to prevent new types of risks while also reducing existing ones. Safety is not a one-time effort. It is a continuous process. Definition of railway safety. When we talk about railway safety, it is important to understand that it has two major components: functional safety and technical safety. Both are essential for keeping the railway system operating safely and reliably. Functional safety. Functional safety deals with the safety of train movement and operations. It ensures that all systems involved in controlling train movement, signals, track circuits, interlocking, train control systems, are reliable. If any of these systems fail, the failure should not create a dangerous situation. Technical safety. Technical safety focuses on the design of the equipment. It ensures that the hardware and software used in railway system follow safety standards and are built to prevent failures that could affect functional safety. In other words, technical safety ensures that a design failure does not lead to an operational risk. Introduction to fail-safe. Now we come to one of the most important concepts in railway safety world. Fail-safe. Fail-safe means that if a piece of equipment fails, it must go to the safest state possible. This principle is mandatory in railway systems because it ensures that no failure can put trains or passengers at risk. Traditional fail-safe concept. In the early days, fail-safe systems were electromechanical. They were built using robust hardware components, redundant wiring, and independent power sources. The expectation was that these systems would never fail. However, when electronics were introduced, it became clear that achieving zero failure is impossible. Modern fail-safe concept. Modern fail-safe design accepts that failures can occur, but tries to reduce the probability to extremely low levels. This is done using redundant processes or devices, continuous monitoring of performance, cross-checking of outputs. If one system fails or gives an inconsistent output, the entire system shifts to the most restrictive or most safe state. Combining old and new concepts. Depending on the type of equipment, old mechanical fail-safe principles and modern electronic fail-safe principles can both be used. Some equipment may rely on mechanical reliability, while others depend on digital redundancy. Both approaches aim to prevent unsafe conditions. Examples of fail-safe design. Let us look at a few examples. Dual filament railway signal lamps. If one filament fails, the other continues to provide light. Signal systems that default to red. If power fails or equipment fails, the signal shows stop. Redundant signaling processes. Two independent controllers must give matching results for a movement authority to be issued. These designs ensure that even during failure, safety is maintained. To summarize, railway safety is an ongoing process that has evolved greatly over time. By combining functional safety and technical safety and the fail-safe principles, the railway system ensures safe and reliable operation. Continuous improvements keep the system ready to handle both existing and emerging risks. Okay, thank you.